Very good morning, my dear friends. Myself, Dr. M.H. Annaya, and in today's video, we are going to learn how to obtain the extreme fiber stresses in a crane hook of trapezoidal section. And friends, the question for today's video reads like this: compute the extreme fiber stresses of a crane hook of trapezoidal cross section. We have got a crane hook of trapezoidal cross section, and the dimensions of that are given as 30 mm and 60 mm, and the distance between them is also given. That is, they have given the maximum diameter or the dimension, minimum dimension, and also what is the distance between these two parallel edges is given as 90 millimeter. The inside radius of hook is given, the capacity is also given, and we are required to find out the extreme fiber stresses. When I say extreme fiber stresses, these are the stresses at the outer and inner fibers of the critical cross section, which are represented as AB. AB is the critical cross section, C is the center of curvature, and this radius of that is also given to be 100 radius. But remember friends, in this problem, the inside radius of the hook is given, the load axis is 25 mm from the center of curvature. That is, it is towards the inner fiber and the load is acting here. In all the problems we have done so far, we used to have the load acting through center of curvature here, but now it is shifted by a distance of 25 mm. So this comes only in the calculation of MB, wherein we take MB is equal to P into RC in regular cases when the load is acting through the center of curvature. But here it is acting 25 millimeter towards the inner fiber. So in the formula of MB is equal to P into RC, we should take MB is equal to P into RC minus the 25, because while computing the bending moment, it's the distance between the load axis and the center of that is the axis CG. So friends, this is how we proceed. And remember friends, in the same problem, if the load were acting away from center of curvature, that is after the C, say, in that case you would have taken MB is equal to P into RC plus that extra distance, whatever the distance the load is being applied from the center of curvature. So there are three cases. One is when the load is passing through the center of curvature, where you take MB is equal to P into RC. If it is towards the inside, towards the inner fiber B, we are going to subtract the distance from RC. If it is to the other side of C, somewhere here, if P is acting, we are going to have MB is equal to P into RC plus this distance. So these are the only three possibilities how the load can act. Now friends, to find out this, what is called the extreme fiber stresses, you have the fundamental equation that is given by the formula. I'll just write down, remove this sketch and write down these values. So first of all, we will see how to compute the values of sigma bi and sigma bi. Friends, sigma I, the total stress at the point B is given by the formula sigma D plus sigma Bi. And remember friends, this is going to be a tensile stress. So sigma D is given by the formula P divided by area of cross section plus sigma Bi is MB into Ci divided by A into E into Ri. This is the formula we have got. Similarly friends, for the other, that is sigma at the outer fiber, that is at A sorry, is given by the same formula sigma D plus sigma B naught. So that is sigma D is P by A plus sigma B naught is minus MB naught divided by AER naught. All these equations are available in the machine design data handbook. Friends, in all my previous videos on this particular chapter, I have told that when MV is positive at one of the extreme ends of the critical section, it will be negative on the other end. When this is positive here, this becomes negative. When this becomes negative, this MV will be positive. Okay, that's a very important concept you should remember. Friends, to get the value of sigma I and sigma O, we should know what is A, what is the load, value of MB, CI, RI, etc. So first of all, let us compute all these parameters that are required to calculate the value of sigma I and sigma O, the extreme fiber stresses. Friends, here if you can just see here, P is the load. The load is given to be 25 kilonewton. That is equal to 25 into 10 to the power of 3 Newton. Then we have got area. Area for a trapezoidal section is given by the formula h by 2 bi plus b naught. That is half of the height into sum of the parallel sides. H is, friends, you can see here the value of h. H is going to be Ri plus x bar, and this is 100 actually. So this is 90, sorry, is given here 90 mm. H is 90. This is Ri is 100. Yes, Ri plus x bar is 100. So R naught will be 190. So half of, that is height is 90 by 2. Bi is this value, that is 60 given in the question. You can just see here 60 mm and 30 mm are the sides. So this is Bi is 60, B naught is 30, and friends, if you simplify, this works out to area equal to a value. Let's find out. This is 90 into 90, 8100 divided by 2. This is 4050, 4050 mm square is the value of this area of cross section. Then friends, you can find out what is sigma d. You can get the value, later on we will calculate. So we can have the value of this area of cross section, load is known to us, and hence we can easily calculate what is sigma d. Then friends, let us see what is RC, Rn, etc. Friends, RC is the distance from center of curvature to the centroidal axis. So this is Ri, and if you call this distance as x bar, so Ri plus x bar will give you RC. So I will write down here, RC is equal to Ri plus x bar. RC is equal to Ri plus x bar. Friends, what is x bar? The distance of this centroidal axis from the inner fiber is given by the formula x bar is equal to h by 3 bi plus twice b naught. This equation is available in the handbooks. Bi plus b naught. Friends, if you simplify this, this works out to h is 90, that is this distance is 90, multiplied divided by 3, bracket bi is 60 plus twice b naught is 30 divided by bi plus b naught 60 plus 30. So friends, if you simplify this value, you will get RC is equal to this. If you simplify 90, this 90 gets cancelled here. So this is going to be 120 by 3, that is 40 millimeter is the value of x bar. That is, from the inner fiber B to the centroidal axis is 40 mm. Therefore, this RC is from here to the center of curvature is Ri plus x bar. So that is RC is equal to RI is 100 plus X bar is 40. So friends, this works out to 140 mm is RC. Friends, let us move on to this Rn. So friends, for the trapezoidal cross section, Rn is given by the formula Rn equal to h by 2 bi plus b naught, that is the area of cross section capital A, divided by bi r naught minus b naught ri divided by h logarithm of r naught by ri minus bi minus b naught. Friends, you know all the parameters. If you substitute in the formula, you will get this value of Rn as 135.4227 mm. Friends, you know Rc, you know Rn, you can obtain the value of E equal to Rc minus Rn. Rc is 135.4227. Sorry, this is RC is 140. Sorry, this is 140 minus 135.4227. This works out to the value is 4.5773 is the value. Then friends, you can find out what is CI. CI is nothing but Rn minus Ri. Rn value is 135.4227 minus Ri is 100, that is 35 point something, 35.4227. So friends, we have all the values required to compute the extreme fiber stresses, namely sigma I and sigma O. Friends, we will write down this again, that is sigma I at B, at the inner fiber of the critical section, is sigma D plus sigma Bi. This sigma D is P by A plus sigma Bi is MB into Ci divided by AERI. Here friends, the value of P, the crane hook has to lift, that's a load, is 25 kilonewton. That is rewritten as 25 into 10 to the power of 3 Newton. Capital A is the area of cross section. We have calculated as 4050 millimeter square because the dimensions of the cross section are in mm units. Then friend, this MB is equal to P into 100, that is RC minus 25, because the load axis is 25 millimeter towards the inner fiber. That's why RC minus 25. So this can be found out. Then friends, CI, the value of CI, we have got the value as 35.4227 mm. MBCI area we know, E value you know is 4.5773 and RI value is 100. So friends, we have got all the values required to compute sigma I. Friends, if you make all these substitutions in the formula, you get this value of the fiber stress at the inner fiber, that is at B, as sigma I 61.109 Newton per mm square. So this is a tensile stress always for any crane hook irrespective of the cross section. And friends, on the same lines, let us find out what is the value of this fiber stress at the outer fiber? So you can write down at the outer fiber, that is at A, sigma O, the total stress at A we will write down is given by P by A plus of minus sigma B naught, sigma BO, that is equal to P by A minus sigma BO is MB C naught divided by AE R naught. Friends, here we know all the values. This C naught is equal to 54.5773. How do you obtain this, friends? Here, friends, that is CO is equal to H minus CI. H is 90 and CI value is 35.42, 35.4227. And friends, this is the value you get. So we got the values of all these. Substitute in the formula and obtain the value of sigma O, stress at the outer fiber. Therefore, sigma O works out to minus 38.38, minus 38.38 Newton per mm square. Friends, we are able to compute both sigma I and sigma O at the critical section of this crane hook of trapezoidal section. Friends, I hope the presentation was interesting. Please go through the complete video without skipping any of these important parameters I have told you. And if you like the video, please share this information with all your friends. Have a wonderful day.